So I have to tell you, my wife's mother was born in Shawnee, and when she was 4, they moved to California in the Grapes of Wrath migration, and my wife and I met in California, sisters, and then and we never thought we'd live in Oklahoma, but 24 years ago, I got a job at the University of Oklahoma, and I've been there since. So here's a picture of the beautiful University of Oklahoma. I'm a professor at that university, which means as a professor, I teach and I do research. My research is currently at Cern Laboratory, which is near Geneva, Switzerland. For 15 years, I did research here at FermiLab, so not very far from here. I would come to FermiLab about 3 days every month for 15 years. I used to joke that I could leave my house in Oklahoma and get to FermiLab blindfolded because I had done it so often, and even drive down 88 blindfolded because I knew every curve in the road. So I want to tell you a little bit about my research. This is what the quiz will be on at the end, so take good notes. I work at a machine called the Large Hadron Collider. It's outside Geneva. It's a circle about 17 miles around. Here's Lake Geneva. Here's the Geneva airport. And the goal of this research, just like at FermiLab, is to discover the structure of the universe. How's the universe put together? So if we want to know how the universe is put together, we have to look inside objects like protons. So how do you look inside protons? There are no tools to take a proton apart. So let's give you an analogy. Suppose you wanted to know how your car was put together. What makes the car run? And you didn't have any tools to take the car apart. What would you do? Well, if you're a brilliant particle physicist, you'd get the car going really, really fast, and you'd smash it against another car going really, really fast, and you'd see what comes flying out. I tell my students, do this with your parents' car, don't do it with your car. But this is what we do. We get protons moving at nearly the speed of light in a tunnel deep underneath the ground, about 300 feet under the ground. And then in that tunnel, protons move one way in one pipe and the other way in another pipe. And at certain places around this big ring, we smash them together. And we see what comes out to understand the structure of the universe. The detector I work at is called Atlas. It's really just a big camera to see subatomic particles. There's a drawing of that detector just to give you some idea of the size. These are people, here and here. So the protons come in 2 pipes, collide in the middle. They make a bunch of new particles. Since E equals mc squared, we actually make mass. Your chemistry teacher will tell you mass can't be created or destroyed, but they lie in chemistry class. In physics, we do it all the time. And then we take pictures that look something like this, and these are all particles created in the collision of protons. And my job as an experimental particle physicist is to understand these pictures that really look like a spirograph drawing that a little kid made, but that a little more complicated. This is one of the 2 experiments, if you follow science news, that discovered this particle called the Higgs boson, colloquially called the God particle, because Leon Letterman wanted to sell books, so he put a provocative title. But we were one of the 2 experiments that actually discovered this particle. In fact, my research now is trying to understand a little bit more about this Higgs boson that was discovered in 2012. So not only am I a professor and a scientist, but I'm also a Christian, and that in and of itself is something that some people think is an oxymoron. How can you be a scientist and a Christian? Isn't science based on objective facts? Christianity based on subjective faith? People ask me questions like, can you be a Christian in the lab, or do you just do your Christianity stuff on the weekend and do your lab, the rest of the time? But there is this perception that to be a Christian, you have to put your mind aside. You have to not ask tough questions. Well, my personality is to always ask tough questions. I'm a skeptic about anything. Drives my wife crazy. She goes, can't you just believe me? And I say, yeah, I believe you, but I still need evidence for everything I believe. So it's interesting, but I believe actually that there's this great coherence between science and Christianity. And that coherence comes because I believe that the God who created the universe, that we study his handiwork, is the same God who wrote the Bible, who came in the person of Christ. And so really, Christianity is a religion that asks you to think. Jesus said that you were to love the Lord your God with all your heart, soul, strength, and mind. And he put mind in there. As Christians, we're to be thinking people. There are a lot of seats up front. Please come on up front. Don't be intimidated. Buzz doesn't spit too bad, so you won't, get too much up there. All right. So anyway, today I want to talk about some of this evidence for God from science. what is some of the objective evidence that I see in science that leads me to believe that there's a God, and particularly the God that's described in the Bible. And I want to describe three things. I want to describe the origin of the universe, the design in the universe, and something called the rare earth hypothesis. So let's start with the origin of the universe. In 1929, at that point, we lived 90 years ago, most scientists believed that the universe was infinite in size and eternal, that it had always existed. There was no evidence for anything else. But in 1929, Edwin Hubble discovered that the universe is a lot like raisin bread. This is raisin bread here, and if you put raisin bread in the oven and it rises, all the raisins get farther apart. And what Hubble noticed is that all the galaxies in our universe were getting farther apart. And if the universe is getting farther apart now, it's expanding. So he made this discovery that the universe was expanding. Now, you don't have to be a rocket scientist. Well, he was a rocket scientist, but you don't have to be a rocket scientist to realize that if the universe is expanding right now, it must have started to expand at one time. So expansion implies that the universe had a beginning or some kind of origin. If it's expanding now, there had to be a start to that expansion. Now, this is not an idea that scientists really like, that the universe might have had a beginning. In 1931, Arthur Eddington wrote this: philosophically, the notion of a beginning of the present order of nature is repugnant. I should like to find a genuine loophole. Okay? And why is this repugnant idea? Primarily because if the universe had a beginning, that would be proof positive that there's some kind of beginner, and that idea was repugnant to Arthur Eddington. But despite the idea that it was repugnant, scientists now have come to the conclusion that the universe had a beginning about 14 billion years ago in something we call the Big Bang. I should clarify that term, the Big Bang, because it's really used in two different ways by scientists, and they never clarify what they mean by it. Sometimes by the Big Bang, they mean the very moment of creation. And when you read in the paper that scientists question whether the Big Bang really happened, they're talking about that very moment of creation, because nobody knows exactly what happened then. But if you go just a little bit time after that, about a trillionth of a second after the Big Bang, from that point on, we kind of understand the history of the universe. And many scientists, when they talk about the Big Bang, are talking about that moment, about a trillionth of a second after the origin. So if we use the term that way, everyone agrees the Big Bang occurred. If we use the term to actually mean the beginning, then there's debate. But mostly, we all believe that this universe really had a beginning. And that's how I'm going to use the term Big Bang, to mean the very moment of the beginning of the universe. Now, even though this idea was repugnant, scientists have come to accept it. Why? For three primary reasons. First of all, the universe is expanding. If it's expanding now, it must have started to expand. Second is we can measure the amount of hydrogen and helium in the universe. These were created in the first 3 minutes, and our theories tell us what we should predict to see, and what we see in the universe is exactly what we predict. There are a couple seats up here. Feel free to come on up and take these seats. So the theory agrees with the experimental results to 1 part in 10,000, which is quite remarkable. And then finally, we measure the temperature of the universe. So what do I mean by that? The universe started out really, really hot, and it's been expanding and cooling since then. But because it was once very hot, we should see some residual heat. It's like the embers left over in a fire from the day before or something. And in 1964, that residual heat was discovered. It's called the cosmic microwave background radiation. And it's proof positive, really, that this universe had this beginning in what we call the hot Big Bang. So these three pieces of evidence, that the universe is expanding, that we can measure the amount of hydrogen and helium, and that the universe has this leftover heat, the CMB, is what's convinced scientists that the universe had a beginning, despite the fact that there are philosophical objections to that. Now, not only do the observations tell us that the universe had a beginning, but so do theoretical calculations. This is a bunch of theoretical physicists who do complicated mathematics, who have all developed theories that show that the universe had a beginning. Einstein's general theory of relativity, and Stephen Hawking and George Ellis and Roger Penrose, who expanded Einstein's theory. And what these four guys came together to say, ultimately, is that the universe had a beginning not just where it started to expand, where space had a beginning, but also time itself had a beginning. So I don't know what it means that time had a beginning. I'm pretty bound up by time. Time keeps marching on. I keep getting older every day. But these guys have come to the conclusion that the general theory of relativity shows that the universe actually had a beginning of space and time. And in 2003, Bourdet, Guth, and Belink and BGV developed a theorem that said any universe that's expanding on average must have had a beginning. So all the science, the observational evidence, and the theoretical calculations come to the same conclusion, that the Big Bang was the origin of everything we know in the universe, space, time, matter, and energy. I've heard so many misrepresentations of what the Big Bang is. I've heard people say it's some cosmic explosion or some collision of gas. It's none of those things. There is no gas to explode. There is nothing to explode. It's the origin of our universe. It's as close as you can come in science to some kind of creation event. And that's the real issue. If the universe had a beginning, if everything in this universe came into existence, all of space and time and matter and energy, then whatever started the universe, the cause of the universe, can't be a part of this universe. That's just logic. If this universe had a beginning, then whatever started it can't be a part of this universe. And that looks a lot like some kind of transcendent being. Well, by definition, it has to be transcendent, not a part of this universe. Now, this idea that the Big Bang origin of the universe somehow leads to a transcendent cause that looks a lot like God is not just an idea developed by Christians or theists. It's an idea that even agnostic scientists recognize. So Robert Jastrow is an agnostic physicist who, as the evidence for the Big Bang became more and more powerful, he wrote this: "For the scientist who's lived by his faith and the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak. And as he pulls himself over the rock, he's greeted by a band of theologians who've been sitting there for centuries." Because the theologians all along have said the universe had a beginning. So this is a remarkable fact. If you were God and you wanted to show your creatures that you created, that you existed, one of the best things you could do is let them understand their origin and see that their origin required a transcendent cause. I think the Big Bang is the best evidence that there is some transcendent God apart from the resurrection of Jesus. And so this is the first evidence that I see points to some kind of transcendent being. The second thing I want to talk about is the design in the universe. In Romans 1:20, Paul writes that we should see God's character, his invisible qualities, his eternal power and divine nature clearly from what has been made. So by looking at nature, we should see the character of God. And I see this when I look at the design in the universe. And I'm going to frame this discussion of the design in the universe in terms of something called the anthropic principle. That comes from the Greek word anthropos, which means humans or mankind. And the idea is that the universe appears to be designed, that many of the parameters, the constants in the universe, seem to be precisely tuned. The definitive book on this was actually written quite a while ago in 1986 called the Anthropic Cosmological Principle. And in that book, Barrow and Tipler, the authors, list about 100 parameters that seem to be finely tuned to allow any kind of life to exist, or even the universe to exist. It's as if you have a control panel with 100 knobs, and those knobs control like parameters in the universe, the speed of light or the mass of the proton. And if you turn those knobs just a little to the left or to the right, you either create no universe at all or a universe inhospitable to life. We've got all night, so I'm going to go through all 100 of these. Yeah, good. You knew that was a joke. That was good. I'm going to explain some of these just to give you a feeling for this type of fine-tuning. The first thing I'll talk about is the strength of the strong nuclear force. So the universe is made of atoms, as we know, and atoms each have a nucleus at their core. The nucleus is made of neutrons and protons are made of things called quarks. Does anybody know what quarks are made of? What do you think?
Based on what I've heard, it's basically pure energy.
Actually, we don't know what quarks are made of. That's one idea. I'm just checking because if we know for sure, we win a Nobel Prize. So I will see what we can do with pure energy, because maybe that one will win the Nobel Prize. No, but you're right. Actually, this theory called string theory says that quarks are made of vibrating strings of energy, and we don't know if it's true or not. But if it's true, somebody's going to win a Nobel Prize for it, so might as well be us. All right, so anyway, the strong nuclear force is what binds the quarks together in the neutron and proton, and eventually bind the neutron and proton together inside the nucleus. So it's the strength of the strong nuclear force that gives us the periodic table. If I was to change the strength of the strong nuclear force, it would change the periodic table. So if you didn't like chemistry class, if you were tired of seeing this hanging on the wall, you can blame the strong nuclear force on that. But if I was to take the knob that controls the strong nuclear force and make it 2% stronger, I would eliminate hydrogen from the periodic table. So that would not be good, right? H2O, water, is hydrogen. Our sun burns hydrogen. You would have no stars like our sun. If you were to take the knob that controls the strong nuclear force and make it 5% weaker, you would only have hydrogen. So chemistry class is really easy. There's just the periodic table. Everybody signs up for chemistry class. But of course, no life without hydrogen. The next thing I want to talk about, so that's the strong nuclear force, is the amount of matter in the universe. So the amount of matter in the universe is finely tuned. And why is that? Because as the universe is expanding, all the matter in one part is attracted to all the matter in the other part. And if there's too much matter, the universe collapses back in on itself too quickly. If there's too little matter, the universe expands so fast that there's no time to form stars or galaxies. And shortly after the Big Bang, about a trillionth of a second after the Big Bang, the amount of matter in the universe was finely tuned to 1 part in 10 to the 60th. So what does that mean? That means if I had thrown 1 dime's worth of matter, taken 1 dime and thrown it into the universe, trillionth of a second after it began, we would not be here. That little bit of matter would have changed the entire history of our universe. Paul Davies, an astrophysicist, writes this: to choose the amount of matter so close to the critical amount, fine-tuned to such stunning accuracy, is surely one of the great mysteries of cosmology. If the crucial ratio had been 10 to the minus 57th rather than 10 to the minus 60th, the universe would not even exist, having collapsed to oblivion after just a few million years. Now, once I gave the talk like this at a university, and someone came up to me and said, you can't use this amount of matter in the universe as a fine-tuning argument, that it's fine-tuned. I said, why not? It's fine-tuned to 1 part in 10 to the 60th. And he says, well, that's true, but we think we know how it's finely tuned. There's a mechanism called cosmic inflation. And cosmic inflation acts in a way in the very early universe to force the universe to have exactly the right amount of matter. It's as if no matter what amount you start with, you get the right amount at the end. And this got me thinking, if I have a mechanism that does exactly what I want it to do, does that eliminate the fact that there's some kind of tuning or fine-tuning? Suppose every week when I need to mow my lawn in Oklahoma, I try to dump gasoline into the little hole in my lawnmower to fill up my lawnmower with gasoline. And the gas goes all over the place. So what do? I employ a mechanism. I employ a funnel. And I stick the funnel in the hole and I dump the gas, and no matter where I pour the gas, it goes in the hole. Now, the fact that I have a mechanism that does exactly what I want it to do, does that eliminate fine-tuning? No, it just gives me how the fine-tuning is done, how the design is incorporated. So it turns out that if you have a mechanism that does exactly what you want it to do, in fact, inflation itself is finely tuned. It's got to turn on at the right time, it's got to turn off at the right time, and this actually is not evidence that there is no designer, but evidence of how a designer accomplishes purposes through some perfectly defined mechanism. So we talked about the strong nuclear force, we talked about the amount of matter in the universe. I want to talk a little bit about another thing I study in my research, the structure of the proton. So the proton is made of 3 quarks at a very elementary level. It's not quite this simple, or I wouldn't have spent 30 years studying it, right? And so in this picture, there are 2 up quarks and a down quark in the proton. But the proton is governed by this science called quantum mechanics. And quantum mechanics is weird. It allows things called virtual particles to pop into existence apparently from nowhere. So every once in a while, within the proton, 2 different quarks called a top and an anti-top quark will pop into existence inside the proton. And together, those 2 quarks weigh 350 times more than the proton itself. It's as if you're walking down the street and two elephants pop out inside of your body for a moment and then disappear. And then maybe later two kangaroos pop up inside your body and then disappear. And this happens all the time inside each of the protons in your body. And they quickly go away. They can't be there for long. And it turns out that not only that in order for us to exist, these virtual top quarks have to exist inside the proton. If they don't exist inside the proton, it slightly changes the mass of the proton. And if the mass of the proton is slightly changed, it takes away the stability of stars like our sun. They don't burn stably. It takes away properties of nuclear decay that are important. And so this is really bizarre. Inside all the protons in your body, these virtual particles are popping into existence. And they're governed by this weird science called quantum mechanics, which nobody understands. But if they weren't there, neither would we be here. Right? It's really remarkable. And if their mass were changed just a little bit, we wouldn't be here either. So I've given you just three things: the strong nuclear force, the amount of matter in the universe, and these things called virtual particles that seem to show the universe's design. Now, scientists recognize that the universe seems to be designed, and so they have things to say, and I could spend all night quoting the kinds of things that scientists say about this design, but I'll just quote one because this is remarkable. Gribben and Rees in their book Cosmic Coincidences write this: if we modify the value of one of the fundamental constants, something invariably goes wrong, leading to a universe that's inhospitable to life as we know it. When we adjust a second constant in an attempt to fix the problems, the result generally is to create three new problems for every one that we solve. Get this: the conditions in our universe really do seem to be uniquely suitable for life forms like ourselves, and perhaps even for any form of organic complexity. Now, scientists know that the universe appears finely tuned. This comes from scientific journals. This is not made up by theists or Christians. This is scientific. But scientists realize that there's got to be an explanation for this. And most of the explanations have been discarded and discredited. But the explanation most scientists believe is correct now is that there are an infinite number of universes. Not galaxies, but universes. And these universes would be ones we would never know about. And if there are an infinite number of universes, almost all of them are inhospitable to life. But here and there you'll find one or two that might be hospitable to life, and we happen to live in the right one. There's no evidence for this. This is all theoretical speculation because we know the universe is finely tuned. But to me, there's a better explanation than a whole bunch of universes that we'll never know anything about. It's that there really is a transcendent, intelligent creator. I mean, if the universe looks like there's a transcendent, intelligent creator, maybe the correct conclusion is there really is. And so that's what I think is the best explanation. Now, people ask me all the time, well, suppose you find an infinite number of universes. Does that take away all these arguments for God? And the answer is no, not really, for a few reasons. First of all, you need to know that there's no evidence for multiverse. There's no that's the term we give to all these universes. There's no evidence at all. There may never be. It's possible, even if they exist, we never know about them, so speculation is not science. But suppose there was a discovery of multiverse. What would that do to these arguments for God? Well, the correct answer is we don't know. The ramifications can only be determined once we know what these multiverse universes are like. There's so many possible ways you could make a multiverse that until we found one, we wouldn't know what the implications are. But still, only a few of them would be able to support life. And it's possible that the laws of physics require multiverse. So the gentleman in the back brought up this idea of energy that quarks are made of. This is a theory called string theory. If string theory is correct, suppose God decided to make the universe based on this thing called string theory. It's possible that the only way to make a single universe based on string theory is to also make 10 to the 500 other universes. So maybe God wants to make one planet with life, and he's going to use string theory as the method, which requires 10 to the 500 universes. And so it's possible that if we actually discover multiverses, we'll find that it's necessary for our existence to have all these other universes. So we really don't know. The discovery of a multiverse may ultimately strengthen the evidence for God. So far, everything we've discovered in science continues to strengthen the evidence for God. A multiverse might do that. But perhaps to me, the most provocative question is the next one. How many universes would an infinite God create? Right? One? That seems like a waste. An infinite? Maybe. I don't know. So to me, you know, the multiverse is not really an issue. If you want more information on this, Jeff Zverink of Reasons to Believe has written a nice little pamphlet called Who's Afraid of the Multiverse? And I highly recommend that. But this idea that the universe is fine-tuned is really an idea based on physics. This is a great book by Luke Barnes and Grant Lewis called A Fortunate Universe. And they say this is a great quote. The reaction against fine-tuning might stem from the belief that fine-tuning is the invention of a bunch of religious believers who hijack physics to their own ends. This is not the case. The field began in physics journals and remains with physicists. While there is more work to be done, physics has tended to consolidate our understanding of fine-tuning. This is a really great book because Luke Barnes is a Christian and Grant Lewis is an atheist. And they wrote a book together. They both agree that the universe is finely tuned. Luke Barnes argues it's because of God. Grant Lewis argues because it's a multiverse. But the beauty of the book is it shows that this idea that our universe is finely tuned is well established. You can't get out of it. It's a scientific principle. Why is it finely tuned? To me, the multiverse isn't even science, it's speculation. But there's lots of evidence that there's this transcendent God. So I've talked about the origin of the universe. I've talked about the fine-tuning of the universe. Lastly, I want to talk about this subject called the rare earth. And the question I really want to answer for the rare earth is what's required in order to have a planet that is capable of supporting higher life forms. And by higher life forms, I mean anything more complex than bacteria. Bacteria can basically thrive anywhere. Now, I know that you know from Star Trek that there's life forms all over the universe, right? And those life forms look a lot like us. They might have bigger ears or green skin or something. But in reality, it's really hard to create higher life forms, anything more complex than bacteria. First of all, you have to be in a spiral galaxy. Only 10% of the galaxies in the universe are spirals. The others are elliptical and irregular. And only spiral galaxies have the right level of star formation and the right level of radiation for higher life forms. This is what our Milky Way galaxy would look like if we could get far from it. And these spirals that look like clouds are about 100 billion stars spiraling around the center. And you can't be anywhere in a spiral galaxy. You got to be from about 1/3 of the way out to about 2/3. If you're too close, there's too much radiation, too close to the center. Right at the center is a black hole, which is not a good place to live unless you're in the movie Interstellar. And then far from the center, there's not enough heavy elements like carbon and oxygen. So there's this Goldilocks zone that you can be in the galaxy, and our sun, of course, is right in this perfect spot in the center of the galaxy. You have to have the right kind of star. Our sun is a class G star. It's the only kind of star that burns long enough and stably enough to support a planet like the Earth. There's other features of the sun I can go into, but for time's sake, I won't. Our planet Earth is unlike any other planet. There's so many factors that make it suitable for life. Its size, its rotation rate, the amount of water on it, even tectonic activity, the activity that causes earthquakes. It's been shown that if you don't have tectonic activity, then you don't have a planet that would sustain water over a long period of time. In a book, The Rare Earth, Peter Ward and Donald Brownlee say that tectonic activity may be, I think I actually have the quote, it may be that plate tectonics is the central requirement for life on a planet and that is necessary for keeping a world supplied with water. So next time you see an earthquake in the news and you ask, why would God allow earthquakes? The right question is, I'm glad, or the right statement is, I'm glad God allows earthquakes. If there weren't earthquakes, we wouldn't be here because we would not have a world that's full of water. The moon plays an important role in stabilizing the axis of the Earth. Jupiter plays an important role in protecting the Earth from stray comets and asteroids. In their book that I quoted, Ward and Brownlee say this: if some godlike being could be given the opportunity to plan a sequence of events with the express purpose of duplicating our Garden of Eden, that's the Earth. If some godlike being wanted to make the Earth, that power would face a formidable task. It is unlikely that Earth could ever be truly duplicated. Now, the rebuttal I get for this from my friends who don't believe in God say, well, there are lots of planets in the universe. And so there must be a lot that can support life. So we can do what's called a back-of-the-envelope calculation. It's an educated guess as to the probability of finding a planet like the Earth. The person who did this back-of-the-envelope calculation is Hugh Ross, the founder of Reasons to Believe, and I borrowed it from him. But a lot of these numbers make sense. You have to be in a spiral galaxy. That's a 10% probability. By the way, if you don't like numbers, just shut your eyes for the next 3 slides, and we'll get through them. You have to have the right distance from the galactic center. That's a 20% probability. You have to have the right star mass and age. There's got to be tectonic activity. We don't know how many planets have tectonic activity. None in our solar system have plate tectonics, so we make a guess, maybe 5%. And you just do the math. This is, by the way, just a partial list of the things we know are required to make a planet like the Earth. Here's a full list, okay? And this is actually an old list. I don't really have the time to update the list, but it's been updated. It's probably twice as long now. This list has 322 parameters that are necessary for a planet to support life like the Earth. And including correlations, if you like doing statistics, the probability of finding one planet like the Earth in the visible universe, what we can see is 10 to the minus 304. Now, there are probably at least 10 to the 23 planets in the visible universe. So the probability of finding a single planet like the Earth is this remarkably small number, 1 part in 10 to the 281st. So the idea that there are many planets that we've discovered over 3,000 so far, there must be one like the Earth, is kind of a naive statement. If you just do the rough math, you find you don't expect to find any planets like the Earth. In science, we have an actual technical term for a number this small, and that term is ain't gonna happen. That's the technical term. All right? So again, scientists recognize this, and they make statements like this. A common sense interpretation of the facts. I like that, right? A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. So the facts indicate that it seems like a super intellect has monkeyed with physics. Now, I want to take one step farther. I've tried to show you that the universe seems to have an origin, that the universe seems to be designed, and that the Earth seems to be rare. But to me, there's a maybe more important question, and that is, so what? So what if the universe is designed? Paul Davies, who's an agnostic physicist, he's not a Christian or a theist, writes this. This is a remarkable statement from somebody who doesn't believe in God. If physics is the product of design, the universe must have a purpose. And the evidence of modern physics suggests strongly to me that the purpose includes us. The evidence of modern physics suggests strongly to me that the purpose includes us. You ever heard that before? That the universe has a purpose and that the purpose includes humanity? Right? Yeah. It's exactly what the Bible states. And he's finding the same conclusion based simply on physics. Alan Sandage was an astronomer who was not a believer in God and saw this kind of evidence and became ultimately a Christian. And he wrote, "It was my science that drove me to the conclusion that the world is much more complicated than science. It's science that drove me to that conclusion. It's only through the supernatural that I can understand the mystery of existence." So in conclusion, here's what I've been saying. I think the discoveries of modern science give abundant evidence for the existence of God, and not just a deistic God, not just a God who started it and left, but a transcendent God who's intelligent, who created the universe and actually has a purpose for humanity. And these are findings from science. And it's amazing to me that these findings from science completely agree with the attributes that are described as the God of the Bible. And so I think this is strong evidence that there exists a being like the God of the Bible. I've only touched the surface on this. I've written a book about it. That's the distinctiveness of this book is it's written in simple conversational language. It's not technical. And then, like most people in the universe today, I have a social media presence. Okay, so if you're interested in more, you can get that.